Okay, here's another example. If you've been following along and it's making sense, please do this one on your own first. Okay, so the first thing we need to do, don't forget to do this, is to write it in descending order. Okay, now is there a greatest common factor? No, so we look at the last term, which is a -6, so that means that I have to have different signs, one positive and one negative. So I could have q plus and 6q minus, but is that the only way I can factor 6? Is that the only way to get a 6q squared is q times 6q? No, I could also get it by using a 2q and a 3q. So here, since 6 has more than one way of factoring, I need to have two factoring frameworks, two things that I check all of my guesses in. I know it's a pain, makes it a little bit long. It's not any harder, it's just longer. Okay, now what would my choices be for the last part of each of those parentheses? Okay, factors of 6. So it would either be 1 and 6 or 6 and 1. Remember, I have to list each factor pair twice. As soon as I have coefficients on the variables in the parentheses, I have to list the factor pairs twice. Or 2 and 3 or 3 and 2. Same thing over here. Okay, let's just start plugging them in and see what works. There's a lot of them. There's 8 of them to check, but the process is just what I've been doing before. So I'll put in 1 and 6, and I'm going to check the outside and the inside to see if I can get the middle term to match. So the outside would give me -6q, the inside would give me 6q. Well, that doesn't give me -5q, so I'll cross that out and then go on to my next choice. Outside would give me -q, inside would give me 36q. Nope, that gives me 35q, nowhere near -5q. Cross it out. I'll go on to the next one. Put 2 in the first and 3 in the second. Outside gives me -3q. Inside gives me 12q. Okay, that gives me 9q, not what I'm looking for. All right, let's try the next one. 3 in the first and 2 in the second. Excuse me. Okay, outside gives me -2q. Inside gives me 18q. That's 16q, not what I want. I want -5q. So again, I cross it out, and I'm just going to keep on going. Okay, over on the second guessing framework, I'll put 1 and 6 in the missing spots. Now the outside would give me -12q, the inside would give me 3q, which is -9q. Not what I'm looking for. Okay, if I put 6 in the first and 1 in the second, -2q for the outside, 18q for the inside, 16q is not what I want. I still am holding out for that -5q in the middle. Cross that out and try the next pair. So if I take the outside, that's -6q, the inside is +6q. Again, not what I'm looking for. Cross it out, so of course it's our last choice, right? Try 3 here and 2 here. Outside is -4q. Inside is 9q. That's 5q. That's not quite what I want, but it's really close to what I want. The only difference is that I want a -5q, and this gives me a +5q. So I'm just going to change the signs. So I get 2q minus 3 times 3q plus 2. First of all, I want to make sure that that makes sense to you. But then I'm also going to tell you a shortcut. Okay, so a few things worth noting. First of all, I needed to write it in descending order. Second of all, I might need 2 sets of parentheses. You might even need 3 sets of parentheses or 3 guessing frameworks. So one guessing framework might not be enough. Then the main thing that is worth noting is I didn't really have to check all of those. If you remember, I know that something is not factored completely if there is a common factor inside one set of parentheses. In other words, I won't have any common factors in a set of parentheses unless I forgot to take out the greatest common factor to begin with. So if we come back and look at that 6q squared minus 5q minus 6, Is there a greatest common factor there? There's not. Therefore, there's a lot of these choices that I could have eliminated. So let's just go back in time for a second. Let's take us back here. We have our two guessing frameworks. We have all 8 of our choices listed. Now this first choice, putting 1 in the first set of parentheses and 6 in the second, I can eliminate that right now. Because if I put 6 in the second set of parentheses, 6q and 6, they have a factor in common. They're both divisible by 6. Therefore, that can't be the right choice. Now if I put 6 in the next one and 1 in the second, that one I might have to check. So I'm going to keep that as a one that I'm testing. Now what if I put 2 in the first set of parentheses and 3 in the second? 3 and 6 have a factor in common. They're both divisible by 3, so I can cross that out. What about 3 in the first and 2 in the second? Again, 6 and 2 are both divisible by 2, so I can eliminate that choice. Let's come over to the second guessing framework on the right-hand side. If I put 1 in the first and 6 in the second, I can eliminate that because 3 and 6 have a factor in common. If I put 6 in the first and 1 in the second, well, 2 and 6 have a factor in common, so I can eliminate that. Now, if I put 2 in the first and 3 in the second, then I've got common factors all over the place. The 2q and the 2 share a common factor, and the 3q and the 3 share a common factor. Therefore, I can eliminate that choice. So I used to have 8 things that I had to check. Now, I've only got 2. Check 6 and 1, that doesn't work. Check 3 and 2, that works except for the sign, and I'm done a lot faster. So just remember, the greatest common factor hint eliminates a lot of choices sometimes, but it comes with a warning label. You have to make sure that you factored out the greatest common factor at the very beginning. If there is one and you forget it, then you will eliminate a valid choice by using the greatest common factor hint. So we know it was okay to use it in this case because 6q squared minus 5q minus 6 does not have a greatest common factor.